Good day, my angels. I'm glad you're here. So again, if you need to write this down, if you want to, if you feel you learn better doing that, you can. But I'd almost prefer if you don't, because then I can go fast. But I do want you to then to learn actively. I'll call on you. I'll ask you guys questions. You may even want a calculator handy just so you can type stuff in on the fly as I write, just to gain practice doing that. I don't know. It's up to you. So much of this test is going to be inclined. Either a ramp where the ground is tilted, or if the ground is flat, the force is going to be tilted like a lawnmower question. So here's a great example. It says a 5 kilogram block remains stationary on an inclined surface. What's the friction force acting on the block? In fact, you know what? I would probably take it one step further, and I would probably say, what's mu? I don't know what's mu with you, except what do I call mu? What's the English phrase for mu? What's it called? So that when I ask for it, you know what the heck we're talking about. The coefficient of friction, okay? Because I figure if I can find the friction, if I can find the coefficient of friction, it's because along the way I found the friction force. So how would we handle this? What would we do first? Mackenzie, what would we do first every single time on all these questions? Are you saying I would like label the forces and do what do you call it, a diagram? Really? Is that what you're saying, Mackenzie? Well, good. If I did say, and I think on one question on the multiple choice, I will ask you what's the correct free body diagram. For this one here, there's a normal force. Which way does this block want to slide? Down the hill. So which way must friction be acting? So I might ask you just for the free body diagram. Now that's the free body diagram. Components don't go on a free body diagram. However, if I want to solve this, I would now say, okay, mg perpendicular and mg parallel. The other key to doing this question, Mitsu, is that right there. What does stationary mean? In terms of forces, yes, I agree. In terms of forces, what does stationary tell me? This is important. It gives me a specific value of something. What? I would make a little note here, hey, that's going to be important. See, normally I would say, who's winning? I think it's going to be a tie. That's why. I usually, if it's a tie, tend to let gravity be the winner because my brain thinks stuff wants to slide down the hill. So in this case, I would go, now, if it wasn't a tie, I would do that, and I could find A. Or if they told me A, I could find friction. Is it a tie, Quinn? Say yes. Why? Because A equals. So really what you're saying is this would be a, but what's M times 0? So really what you're saying, Quinn, is that this whole side would be a 0. Except couldn't I just plus the negative FR over to this side? So really, Quinn, I think what you're saying is it's a tie. That's the 3-step little domino chain. Okay. So if it just said find the friction force, I would say the friction force is mg parallel, mg 2 lines. Help me out. So I would go, it's mg sine 25, and I would have answered the question that I crossed out. Only, what did I say instead? What do I want to find? What's mu? Oh, where does mu appear? Well, here, friction is what times what? So then I would say, okay, and I think I can do this, Mr. Dewick. I hope. Yep. I would say, okay, mu times the normal force equals mg sine 25. I don't know the normal force. Oh, but look. Another I know another force the same size as the normal force. And hopefully you're starting to see, Kyle, the rhythm and the routine. That stupid look thing that I do is really to let you know, please look, there is another force the same size as the normal force. Which force is the same size as the normal force? Mg perpendicular. I get those mixed up all the time too. If you say it wrong, as long as you write it right, I don't care. Right? So if I hear you correctly, what you're really saying is, by the way, which trig function is perpendicular? Of course it is. So you're going to get this. This is kind of a neat one because is there an M in everything? Turns out I didn't need to give you the mass, although the question did. Oh, strangely, is there a G in everything? How would I get the mu by itself?
Divide by cos.
Yep, divide by cos. So mu is going to be sine 25 divided by cos 25. Whatever the heck that is, I'm going to assume you can type that into your calculator, yes? What are the units for mu?
None.
None. Okay. You can almost certainly expect a question on your test somewhere where I say, hey, what's mu? Ask you to find a coefficient of friction. And usually what I'm really saying is find the normal force, find the force of friction, because to get the mu by itself, it's friction divided by the normal force. Okay? What else? You might get a question where I ask you to find a missing mass. Now, if I'm going to ask you to find a missing mass, I either have to give you the acceleration or the tension. In this case, they gave me the acceleration. So it says, if the system accelerates, you know what? Just to make this a totally different question, if you're wondering how I make some of these up, I'm going to go like this. There, now it's a whole new question. Okay. If I knew both masses, I would go like this. I would probably, Mackenzie, how would I start out this question? What would I do first, Mac? You mean you label the forces? You mean like I'd actually label things and draw things? Hey, that's a great idea. I would say this is M1G because clay, there's more than one mass, so I'll probably number my masses because that would be clever because it takes almost no work and helps me stay organized. Right. Is this cart sinking into the ground like quicksand? Are we flying into like Superman? And we're on flat level ground. I think I can say there's normal force number one. There's a rope, tension. Is there friction? I think the cart is meant to suggest no friction. Yay! M2G, tension. If I knew both masses and said find acceleration, your equation would be winner minus loser plus winner. Oh, a lot of people want to put M1G into here, but notice I'm writing the forces along the rope. Does M1G appear along the rope? No. Do you know why M1G doesn't appear? Because there's no friction. If there was friction, I'd have friction going this way. Friction is what times what? Mu times the, I don't know the normal force. Oh, but look. And that's where the M1 would end up showing up. But since there's no friction, it's not going to show up on the left side. It will show up, though, over here. Because you are still having to drag it along. Did I give you the mystery mass M1? No, but that would be if I gave you both masses and said find an acceleration. You okay with that, Dustin? That's not what this question says, find the mass M of the cart. To do that, I'm going to look at the mass that I do know, the M2. Dustin, my friend, looking at M2, who's winning? Which way is this accelerating? So who's winning? You're telling me tension's winning? I don't think so. Which way is accelerating? Which force is pointing down? Who's winning? That's what you said the first time, right? Yes. No one noticed. Who's losing? Tension. And that's going to be M2A. I have to do looking at one mass because they only gave me one mass. I'll look at the mass that I know. But the nice thing is I think I can find tension now. I think, oh, we've seen this dance before. Plus that over, minus that over. I'm going to get M2G minus M2A equals tension. I'm going to get tension equals M2. I made up a new one, 5.6, G 9.8, minus 5.6 times, what did I say, A, 3.2? The tension is 36.96. This is not my final answer. I won't round off. I'll keep everything. I'll write 36.96 newtons. It's not what this question wanted me to find. What did this question want me to find? The mass. Let's go write an equation for the mystery mass then. So now I go back and I look at the cart. Who's winning? Which way is the cart accelerating? Who's winning?
Tension.
Has to be. That's Newton's first law. If accelerating to right, there has to be a winner, right? So let me ask again. Who's winning?
Tension.
Who's losing? No friction. No one. You know what? My equation now is going to be tension equals M1A. Now, if there was two masses, what would I now do? I get the masses to one side. I would turn it, grade 9 mathematical operation, pull it out of my back pocket, GCF. Here, this is nice, only one mass. How would I get the mass one by itself? It's going to be tension divided by the acceleration. It's going to be 36.96 divided by the 3.2. The mystery mass is 11.55. I'll call it 11.6. 11.6 what? Kilograms. Somewhere on your test, I'm going to give you two masses, one of which is missing. I'm going to give you either the acceleration or the tension. I'm going to say find the mystery mass. Mr. Dewick? Yeah, Cade. Here they gave us the acceleration. Yeah. What if they gave us the tension instead? If they gave me the tension, if they gave me this value, Cade, could you find the acceleration? Using this equation here. And now that you have tension and acceleration, it's going to be the same shtick over here. So either one. On your test, there's going to be an algebraic question like this. Okay? In fact, you're going to find a lot of the time this year, you're going to start to get algebraic questions. And you can solve these algebraically, but I realize for now, probably we'll solve these with numbers. But here's what it says. A force acts on a mass m, causing it to accelerate at 4 meters per second squared. What if the mass is twice as big? What will happen to the acceleration with the same force? My gut is half as big. My gut is B, 2 meters per second squared. But I just counted that with a gut. How would I handle this if I was trying to actually crunch the numbers? You know what? Did they give me an acceleration? Bear with me for 1 second. My pen stopped working. So since they gave me the acceleration for, why don't I just make up a nice mass? How about 3? I wouldn't pick a mass of 2 because I'd be worried I'd get it confused with that. Or, you know what? I'll just pretend the mass is 3 kilograms. If that's the case, how big is force F have to be? Really? What's the mass? What's the acceleration? What's the force? What's the mass? What's the acceleration? What's the force? What? Why? Because F equals, I'm using F equals ma. So if the mass is 3, then this has to be 12 newtons. So down here, I also see 12 newtons. What's the mass? 2m. What was my original mass? 3. What's 2m? It's called the tension span. I want you to hear. What's 2m? Oh, if you have 12 newtons and 6 kilograms, what's your new acceleration? 2. So that's the way to do it with numbers. I'll walk you through how to do it algebraically some other time. Okay. Lawnmower question. There's going to be a lawnmower question or two on your test. By the way, with this method, is she raising or lowering the normal force? Is she raising or lowering friction? Is she making it easier to accelerate or harder to accelerate? What if instead she was pushing down on it with a stick? What if she was pushing down on it? What would that do? Raise or lower the normal force. Raise or lower friction. Make it easier or harder to accelerate. Okay? So that's really the concepts we're getting across here. There's some beautiful thinking that you guys have taken for granted because, again, I'm assuming most of you along the way, if you haven't already, you're going to be asked to move furniture. You got strong backs and weak minds. Your friends are going to ask you to move some furniture, and you're going to clue in, oh, if we lift as we slide, it's way easier. If I push down as I slide, I'm an idiot. Okay? I think on your quiz, we had this stay at rest and not move at all, which told you if it was staying at rest, the acceleration. What was the acceleration? 0. Here, it wants the acceleration. Okay. Hey, Mac, any thoughts on how I might start this? Why did I draw the normal force so much shorter than gravity? Okay. I think on your quiz, I drew friction the same size as Fx. Here, since it does say we're accelerating, I'm just going to emphasize friction's not going to be as big as Fx. Now, that would be my free body diagram, 1, 2, 3, 4 forces. But they didn't say draw the free body diagram. They want the acceleration. So I'll fill in the components. I'll go d, 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 d. Here's Fx. D, 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 d. Here's Fy. Who's winning? Who's losing? So my starting equation, it's going to start there. What's this question asking me to find? Yeah. Okay, now we're probably going to be doing some heavy-duty trig, but there's my starting point. Oh! They gave me the friction force in this question. That's nice. Now, if they didn't, then I would go friction equals mu times the normal force. They would have need to have given me mu. Then I would say, I don't know the normal force. Oh, but ugh. Look. I know 2 upwards forces that equal mg, and I could figure out the normal force by doing some calculating. Is that okay? But here, they gave me friction. So A is going to be, mass is 35. Friction is 55. All I got to do is plug in Fx. I think Fx ends up being adjacent hypotenuse. I think Fx ends up being 140 times the cosine. So it's going to be 140 cosine of 28. Whatever the heck that is. I can fit this in a little better. 140 cos 28. I'll be honest, on your lawnmower question, I just yoinked this from one of the reviews because the diagram was pretty. I'm not going to give you friction. I'm going to make you calculate friction. So you would then say, well, what is the, I think the normal force here would be gravity minus Fy, and that's why the normal force is less, because you're subtracting from the standard mg, where Fy is, I'm pretty sure, sine. Is that okay? Now, how can I gum this up? I guess the only other thing, I could tell you A, and work your way backwards and find friction or find mu. Because if friction is mu times the normal force, mu is friction divided by the normal force, and you'd be able to find all of them. Okay. Is that all right? I told you there's going to be a question where we're on an incline, but I'm going to ask you to do something with it. In this case, it looks like I'm saying, oh, find mu. Find mu. That wasn't loud or distracting. Someone's shedding. Says, find the coefficient of friction. Okay. Mac, how am I going to start this? Are you picking up on my hint, by the way?
Yeah.
You are?
No, I got it right away.
He was asking me to help him with homework, but he hadn't done any pictures, any free body diagrams. He was trying to do it all. By the way, if you want my criteria, I can do all of these in my head confidently. This is where I hit the wall. I can, if you don't interrupt me, I can do an entire lawnmower question on my calculator showing no work. But if you distract me or interrupt me, and to be honest, usually I need to write the first main equation out, and then I can do the rest up here. So don't try.
No, I don't. There's just those two.
Yeah, no, it's also a chance to damage your self-esteem because, you know, it's fun. Hey, which way is this thing sliding?
Down the hill.
Which way is friction?
Up the hill.
This would be your free body diagram, but they want me to go further. Okay. Oh, sorry. Components should really be done with dotted lines. MG perpendicular. MG parallel. Who's winning?
MG parallel.
Yep. Who's losing?
Friction.
Okay. This question gave me the acceleration. Yay! It wants me to find mu. I don't see a mu. Oh, friction is what times what? Starting to see why I went so ballistic if any of you said friction was mu mg, because it's not. Rarely is. Physics 11, yeah, but physics 11 is boring. What am I trying to find? Mu. You know what? I would get the mu by itself. Now, this is not a rule tie. I hate it having a negative in front of the mu, so I would choose to plus this over and minus that over. I would write this as mg parallel minus ma equals mu fn. I think that looks prettier. I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. What? So do you mind? I'm going to go... Oh! This is good because even though they said a 5 kilogram block, Ty, is there a mass in every single thing here? Which, again, just for nerd trivia, replace the block with kids and adults skiing. It's why different masses of people can ski next to each other without constantly having to adjust. Now, there's also air resistance and things, so you do have to do some adjustment in real life, but nowhere near what it would be if the masses didn't cancel. Okay. In fact, Ty, how would I get the mu by itself? What would I do with this G perpendicular? Can I do this? G sine is going to be 9.8. Sorry, G2 lines, whoops, it's going to be 9.8 sine minus, and then G perpendicular is going to be 9.8 times. Of course it is. I'll let you take it the rest of the way. Okay? So that gives you an idea of, instead of me saying find the acceleration, I'll give the acceleration, find mu. Or, sometimes they can sneak in a question that's actually way easier than you realize, but they didn't give you a picture, and because they didn't give you a picture, Mac, that makes it way, way tougher. Because there's no picture. It says this: a 65 kilogram block is being accelerated along a level surface. The applied force is 500. Friction is 300. What's this question want me to find? Mu. Now, I started out saying to myself, who's win? And then I went, wait a minute. Kiowa, what's this question asking me to find? What's the equation that has mu in it? The only one. Can you what's the equation that has mu in it? Something equals something. I'll give you a hint. Something equals mu times something. The whole thing, please. Ty, what? Ty, what? Ty, what? See, I was all set to go winner minus loser, but then I went, hey, wait a minute. How would I get the mu by itself? Did they tell me the force of friction? 300. I don't know the normal force. Oh, wait a minute. I do know the normal force. It's going to be... so I was all set to go winner minus loser, but I think mu here is just going to be 300, the friction force, divided by... You know what? This would be a great multiple choicey kind of question, because I'll bet you some of the answers are if you went winner minus loser and started, oh, well, it's 500, take away 300, 200 is my net for, oh, divide by the mass, I find the acceleration. And you know what? They tricked me. They gummed this up to make it look tougher than it was. Is that okay, Kohei? Say yes. There. 3 masses is probably overkill, but if we can handle this, we're in good shape. I'm trying to remember, I might have put a 3 mass on the multiple choice as a nasty. I definitely didn't put a 3 mass question on the written. I think. Yeah, I'm sure. So, here's a lovely 3 mass question, and they want me to find that. Tension 1. Okay. Who's winning? Oh, you know what? Before I even do that, I should probably, what's the word that I'm looking for there, Mac? Label the forces, you say? Okay. Clay, since there's 3 masses, I'm going to be clever, and I'm going to call this M1. And I guess I'll call this tension 2, even though it's the first rope, because they called tension 1 that rope over there. So not to confuse myself, go with it. Looks like here I'm going to have M2G. Normal force, tension 1, tension 2. Is there friction on this object? Yeah. Which way is this 12 kilogram mass going to accelerate? Because the heavier mass, which way is friction then? And I'll call it friction force 2 to go with mass number 2. Even though it's the only friction force, I'll just be consistent. Oh, and then... M3G tension 1. I think I'm going to find the acceleration of all 3 masses, and it's going to be the same because they're attached by rope. Then I'll go write an equation that it has tension 1 in it. Because in my big equation, what's going to happen to all my tension, dudes? Oh, cosmic cancel, right? So who's winning? It's going to be M3G, and then it's going to be minus tension 1 plus tension 1. And then it looks like I'm going to have minus friction force 2. I'm not going to put M2 in because it's not in the same direction as the rope. And then it's going to be minus tension 2 plus tension 2 minus M1G, and that equals the mass of all of them times A. I guess the acceleration is going to be, yay, it's going to be divided by the mass of all of them, and it's going to be M3G minus mu times normal force number 2 minus M1G, because friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I do know another force the same size as the normal force. Yes. Need more room, Mr. Dewick. There we go. The acceleration is going to be M3G minus, what did we say the coefficient of friction was? 0.28, right there. Mass 2, 12, times 9.8. There's my normal force. Minus 2 times 9.8. All over 2 plus 12 plus 18. I think 33 if I do the math in my head. Let's really quickly crunch this. 18 times 9.8. Take away 0.28 times 12 times 9.8. Take away 2 times 9.8. Typos? No. Divided by bracket 2 plus 12 plus 18. I get 3.871. That's nice. Acceleration. I'll write down the whole thing because this is not my final answer. What did this question really want me to find? I don't know. You scroll down, Duick. Oh, what did I circle in blue there? What does it want me to find? Tension 1. Okay, let's write an equation for one mass. Should I use the 12 or should I use the 18? Yeah. In fact, if I wanted to do that now, I would say, looking at the 18, who's winning? M3G minus tension 1 equals M3A. I think tension 1 is going to be M3G minus M3, that A. Whatever the heck it is. Is that okay, Kyle? You could crunch it from there. So there's an example of a multi-mass, a 3-mass. I don't think I'm going to throw a 3-mass at you, but we can handle it. You okay, Kiowa? You're not foolishly on your phone or anything like that? That'd be silly. Silly again, I say. Hey, here's another one. Here we have an incline. Oh, but this time, let me make this a little smaller. This time, this question is asking me, we did one kind of like this on the big take-home quiz, except I think there I said find time. Are you guys, I can do this, or if you feel you're okay with finding the acceleration when you're on a ramp and then using that to find something else, I can pass on this one. You're good? Were you packing up, or you can?
Yeah, I got to go.
Okay, so this will get put online, or and I'll email it out and whatever. Do you guys want me to do this, or do you want me to move on? Sure thing. What are the forces acting on this? Hang on, my pen stopped working. Oh, let's also do that. Sorry, what were the forces acting on it? Say it again, kiddo.
Gravity.
I totally agree. Normal force, yes. Which way is this sliding?
Up.
Does that mean there's a force pointing up? Say no.
Down.
Friction. In fact, this is going to slow down really quick because also when I break gravity up into mg perpendicular and mg parallel, there's two forces slowing it down. Which two forces are slowing it down?
Friction and mg parallel.
In fact, it's winner plus winner. It's going to be mg parallel plus. Now, why did I start here when it was said find the distance? Well, really what I should have said is, look, they want me to find this. They did say stops, so V final is what? What's V initial from the picture?
7.5.
And I would say, you know what? If I can find the acceleration, I'm good to go. There's my argument. How would you get the A by itself in this lovely forces question?
Wouldn't you divide it all by like m? Oh no, sorry.
Yeah.
Yeah, by m.
So I can go further. A equals mg 2 lines. I think you're suggesting that's sine of 30, yes? Plus mu times the normal force. Rats, I don't know the normal force. Oh, but look, 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 look. I know the force is the same size as the normal force. Which one?
Mg perpendicular.
So are you saying that I can write this as mg sine 30 plus mu mg cos 30? You know what I really could have done, by the way? I could have just kept it as ma, and I could have said, hey, is there an m in everything? So I could have just done that instead of dividing. You know what? I'm going to do that because that's cooler. That's nerdier. Only works if there's an m in everything. If I was missing an m somewhere, I'm out of luck. In fact, you know what? On lawnmower questions, the mass won't cancel. I'll tell you that right now. It's going to be 9.8 sine 30 plus mu is 0.2 times 9.8 cos 30. There's my acceleration. I'll go 6.5974 because I'm going to use this. 6.5974. And I'll walk that over to here. Hey, which equation has a d, a vf, a vi, and an a in it?
D equals VF minus VI over A.
Curse you. That's not an equation. Never has been. So I got to erase that. Never been an equation. I don't know where you guys got that from. You know, if your teacher was good, he'd have a, what's the word he's looking for? Second word is sheet. First word begins with an F. Colored paper. What's it? Oh, a formula sheet. See it?
Yeah.
Now, by the way, I'm glad you made that mistake because it drives me crazy. Which equation? Read me the proper original equation. Which one?
VF squared equals, so the V0 is that initial? Or,
I don't know.
yeah,
Yeah.
equals VS equals 3D.
Okay. Now get the d by itself.
VF squared minus VI squared over 2K.
Do you see the difference from what you read me?
Yes.
You, for some reason, did this. No, those twos don't cancel. No, that's not an equation. That's not an equation. Those are there. Okay? I think we're going to run into one little glitch because I think if we go 0 squared minus 7.5 squared all over 2 times 6.5974. Look at the top. Will the top work out positive or negative? What about the bottom?
Positive.
You know what? Are we speeding up or slowing down? We would have to actually add a negative there to get our positive distance up the hill. Whatever the heck it is, I'll assume you can type that in. Okay, so that would be an example of the kind of questions, an example of a question where I'm giving you a hill and I'm saying do something with it. Does anybody have any specific questions from the review or from the homework? Because apparently those are the ones that I wanted to give hints and talk about. Then if you want to get out your ultimate review, I'm going to go like this. Questions that I like. Oh, before you go, it's going to be an elevator question. I'll even be more specific. It's going to be on the multiple choice. I'm not going to, an elevator question for a written question worth 7 marks, 2 easy. It's going to be an elevator question, though. So, number 1 would be a good example of an elevator question. So I like number 1, I like number 1, I like number 1. I like number 2, I like number 2, I like number 2. Somewhere I'm going to be asking you to find a mu. I like number 3, I like number 3, I like number 3. So far, so good. Somewhere on the multiple choice, I'm going to be asking you a question about Newton's laws. So I'll say I like number 4. In that, I'm going to be asking you a question about Newton's laws. Number 5, how many masses in number 5? 3. I told you I'm not going to put a 3 mass. I don't mind it, but it's going to be a 2 mass question. So you can kind of say, don't freak out about it, but still try it. Oh, 6 is great. Here's a perfect example of, here's an incline, here's a hill, but instead of saying find the acceleration, I'm saying find a distance. Coming to rest, when it says that, what's coming to rest telling me? That phrase, what does it tell me?
VF0.
VF0, okay. It looks like VI, or as we like to call it, V0 is the initial velocity. Just saying. Number 7, I like part B in particular. Somewhere on your test, I'm going to ask you to find a mass. Eight is good, finding mu again. Number 9, I think we did that one together, but there is going to be some kind of an algebraic question. So I like number 9, I like number 9, I like number 9. You've liked a lot of these because this is fundamental. Oh, number 10, I like number 10, I like number 10, I like number 10. Here's a lawnmower question. Um, 12, finding a mystery mass. This time with friction, makes it a little more interesting. Oh, no. Frictionless, really? Okay. 13, lawnmower question. Is good. Somewhere like number 15, I'm going to ask you to draw on the multiple choice section a free body diagram, and I will ask you to draw a free body diagram on your test on the written section as well. 16 is the same as finding a mass. We've done a couple of those already, but if you know, there's going to be finding a mass question here. I don't. Let me pause for 1 second. I'll tell you right now, on your test, I didn't give you an Atwood machine, 2 masses, and an incline hill in the same question. I did on your take-home quiz, right? There was the one question where it's hanging over a cliff and sliding downhill. You know what? I assessed you on the quiz. So 17 you can certainly try. You're not going to have one quite that nasty on your test. I mean, you got to do them all, but something like number 26 is fair game, where you have an Atwood machine and friction. I think that's more realistic. Right, 2 masses, a pulley, but also friction. That makes it more physics 12-ish. .32, like drawing a free body diagram for something on an incline, sliding at a constant speed is good. 33, elevator question, absolutely. Oh, that's it. I don't know yet, hang on. So, by the way, I'll say to me, 39, if you look at number 39, is this an Atwood machine? Are there 2 masses and a pulley? Say yes.
Yeah.
Is there an incline?
Yes.
So I'm not going to give you one this tough on your test, but this is a scholarship question. I gave you one like this on your quiz. This is the second or third question on your quiz had a hill, 1 mass hanging down, and I had friction and the whole schmear. So you guys handled it just fine, but I've already assessed that. Okay? Other hints. Think about some of the demonstrations that I've done during this unit. Push-ups, walking, book against the glass. You know what? Some of those somewhere along the way might reappear in altered form, because those to me are fair game as well. Any other questions at all? You good, Kiowa? So let me pause the video.